In the early years of the global war on terror, the United States military faced a catastrophic inversion of its doctrinal assumptions. For decades, the philosophy of ground mobility was predicated on speed, low profiles, and maneuverability, a lineage that culminated in the high-mobility multipurpose wheeled vehicle, Humvee. The Humvee was a machine designed for the Fulda Gap, intended to ferry troops behind the lines of a massive Soviet tank engagement. However, in the urban sprawl of Fallujah and the dust-choked supply routes of Anbar Province, the enemy voted against this doctrine with the Improvised Explosive Device, IED. The physics of the battlefield shifted from horizontal ballistics to vertical acceleration. The flat-bottomed Humvee, essentially a pickup truck with bolted-on steel plates, became a thermodynamic trap. When a buried charge detonated beneath it, the blast wave took the path of least resistance, obliterating the floor pan and transferring lethal kinetic energy directly into the crew. The answer to this crisis was not merely thicker steel, but a radical rethinking of vehicular geometry. It required a machine that ignored the traditional automotive virtues of aerodynamics and ride comfort in favor of pure blast deflection. Enter the Cougar mine-resistant ambush-protected vehicle. Born from the desperate urgency of the urgent operational requirement and forged in the empirical fires of the South African Bush War, the Cougar was less a truck and more a bank vault on wheels. It was an ungainly, towering, mechanical beast that handled like a capsizing ferry and drank diesel with gluttonous abandon, yet it accomplished the singular engineering metric that mattered. It kept the biological components inside, the United States Marines and soldiers, alive when the world exploded underneath them. If you enjoy deep dives into the engineering and battlefield realities behind modern armored vehicles, consider subscribing. There's a lot more coming. This report provides an exhaustive technical analysis of the Cougar mine-resistant ambush-protected vehicle, dissecting its monocoque anatomy, its reluctant automotive heart, the evolution of its suspension from spine-crushing stiffness to independent articulation, and the grim realities of maintaining a 17-ton armored capsule in the crucible of combat. To understand the Cougar, one must understand the behavior of high-pressure gas. When high explosives detonate, the resulting shockwave expands spherically at supersonic velocities. Against a flat surface, like the underside of a standard military truck or tank, this wave strikes perpendicularly at a 90-degree angle of incidence. In this scenario, the transfer of energy is maximized. The hull plate absorbs the shock, deforms, and often shatters, while the entire vehicle is launched upward by the overpressure. The Cougar's primary defense mechanism is not the material composition of its armor, but its shape. Derived from the lineage of the South African Caspier and Hippo vehicles of the 1970s, the Cougar utilizes a deep, sharp V-hull. This geometry forces the blast wave to engage the hull at an oblique angle. Instead of absorbing the blow, the V-hull deflects the blast energy laterally, venting the superheated gas and debris out from under the vehicle rather than through it. This is not dissimilar to the principle of a boat hull cutting through water, but occurring at velocities exceeding 6,000 meters per second. The hull extends fully from the front bumper to the rear step, ensuring that a detonation under the engine bay or the rear axle is shunted away from the vehicle's center line. A critical engineering distinction that separates the Force Protection Incorporated Cougar from many of its mine-resistant ambush-protected vehicle contemporaries, such as the International Max Pro, is its construction methodology. The Max Pro is essentially a heavy-duty commercial truck chassis, a modified International Workstar, with an armored box bolted onto the frame rails. While this allows for rapid manufacturing using existing assembly lines, it introduces a structural vulnerability known as hull separation. In a catastrophic blast event, the bolts securing the armored capsule to the chassis can shear, causing the crew compartment to detach and tumble, effectively disconnecting the passengers from the vehicle's mass. The Cougar, integrated by Spartan Motors, utilizes a monocoque design. In this configuration, the armored capsule is the chassis. There are no frame rails running the length of the vehicle. The suspension subframes, engine mounts, and drivetrain components are bolted directly to the armored spine. This creates a unified structural entity with immense torsional rigidity. In the event of a massive improvised explosive device strike, the external components, the wheels, axles, and even the engine block, are designed to act as sacrificial elements. They absorb energy as they are ripped away, leaving the central citadel intact. This design ensures that the crew capsule remains a single, survivable unit, protecting the occupants from the secondary trauma of structural disintegration. The manufacturing process involves forming heavy plates of high-hard armor steel into the complex angular shapes of the V-hull and welding them into a continuous tub. This requires specialized fabrication techniques that differ significantly from standard automotive stamping. The resulting structure is incredibly heavy, contributing to the Cougar's 32,000 to 38,000 pound curb weight, depending on the 4x4 or 6x6 configuration. But it provides a level of integral integrity that bolted-on armor cannot replicate. Motivating a vehicle that weighs as much as 3 city buses requires a prime mover that prioritizes low-end torque and durability over acceleration or top speed. The Cougar is powered by the Caterpillar C7, a 7.2-liter, 441 cubic inch, inline-6 turbodiesel engine. In this military application, the C7 is tuned to produce approximately 330 horsepower, 246 kilowatts at 2,400 revolutions per minute. However, in the world of heavy armor, horsepower is largely a vanity metric. The figure that dictates the Cougar's ability to climb out of a wadi or push through deep sand is the torque, 860 pound-feet, 1,166 Newton-meters. The selection of the C7 was driven by the necessity for commercial off-the-shelf components to meet the rapid fielding timelines of the mine-resistant ambush-protected vehicle program. It features the Advanced Combustion Emissions Reduction Technology Air Management System and a common rail fuel injection system commanded by an electronic control module. While reliable in industrial applications, the operational environment of Iraq placed extreme thermal stress on this engine. The V-hull design necessitates that the engine sits high and deep within the armored nose, shrouded by heavy steel plate. This restricts airflow significantly compared to a commercial truck. The cooling stack, located at the front, had to cope with ambient temperatures exceeding 120 degrees Fahrenheit, 50 degrees Celsius, while the engine operated at maximum load, pushing a brick-like drag coefficient through soft terrain. Transferring this rotational force to the wheels is the Allison 3500 SP Series 6-speed automatic transmission. The choice of an automatic transmission was non-negotiable for several reasons. First, it lowered the training threshold for operators who might be 19-year-old infantrymen used to driving civilian sedans. Second, and more importantly, it maintained torque delivery during shifts. In deep mud or sand, the momentary loss of momentum during a manual gear change can cause a 17-ton vehicle to bog down instantly. The Allison 3500 SP includes a torque converter with a lock-up clutch, bridging the gap between fluid coupling efficiency and direct mechanical drive, which helps mitigate the transmission heat generation that plagues heavy armored vehicles. The drivetrain feeds into a 2-speed transfer case, allowing the driver to select between high and low ranges. High range is utilized for convoy operations on improved surfaces, where the vehicle is governed to a top speed of 65 miles per hour, 105 kilometers per hour. Low range is reserved for technical terrain, recovery operations, or climbing steep gradients, effectively multiplying the torque to crawl over obstacles. The 4x4 variant, Cougar H, utilizes a permanent all-wheel drive system, while the 6x6 variant, Cougar HE, adds a third-driven axle. The 6x6 configuration is particularly favored for its lower ground pressure, distributing the immense weight over a larger footprint, which is critical for preventing the vehicle from sinking to its axles in the soft alluvial soils of the Euphrates River Valley. The early production Cougars, fielded hurriedly in 2004 and 2005, were equipped with standard heavy-duty leaf spring suspensions and solid beam axles. This setup, while robust and mechanically simple to repair in the field, had severe limitations when applied to the mine-resistant ambush-protected vehicle's unique mass distribution. The Cougar has a remarkably high center of gravity due to the V-hull pushing the cabin upward. The ride quality of the leaf-sprung Cougars was notoriously punishing. The stiff springs required to support the armor weight meant that every corrugation in the road was transmitted directly into the chassis. Soldiers riding in the rear over rough terrain were subjected to violent vertical accelerations. Anecdotal reports from the field described the ride as bone-jarring, with crews suffering from fatigue and spinal compression injuries simply from the transit, absent any enemy action. Furthermore, the solid axle setup limited wheel travel. If one wheel encountered a significant obstacle, the rigid axle would pivot, often lifting the opposite wheel off the ground or inducing dangerous sway in the top-heavy vehicle. This contributed to the Cougar's initial reputation for being unstable and prone to rollovers in complex terrain. As the theater of operations shifted toward the rugged, underdeveloped topography of Afghanistan, the mobility limitations of the solid axle Cougar became a tactical liability. The United States Marine Corps and Force Protection initiated a massive retrofit program, integrating the Oshkosh TAK-4 independent suspension system. The TAK-4 system represented a quantum leap in armored vehicle mobility. Originally developed for the Marines' medium tactical vehicle replacement truck, the TAK-4 system replaced the solid axles with massive double wishbone control arms and high-capacity coil, springs at each wheel corner. The TAK-4 system provided up to 16 inches of independent vertical wheel travel, more than double that of the original leaf spring configuration. This allowed the wheels to track over boulders and ditches while keeping the hull relatively level. The isolation of wheel movement drastically reduced the shock transmitted to the crew, mitigating fatigue and protecting the sensitive onboard electronics from vibration damage. The independent suspension system allowed the Cougar to maintain higher speeds off-road. Where a solid axle Cougar might have to crawl at 5 to 10 miles per hour to avoid shaking itself apart, a TAK-4 equipped unit could traverse the same terrain at 20 to 30 miles per hour. Crucially, the independent suspension improved the vehicle's side slope capability to 30% and its grade climbing to 60%, reducing the rollover risk. This upgrade also facilitated the integration of a central tire inflation system, allowing the driver to adjust tire pressure from the cab, deflating for soft sand traction and inflating for hardball roads, without exiting the safety of the armor. The Cougar's armor is a classified composite, primarily consisting of high-hard steel, capable of defeating 7.62 millimeter armor-piercing rounds and surviving the detonation of significant explosive charges, specifically 30 pounds of TNT under a wheel and 15 pounds under the center hull. However, stopping the penetration is only half the battle. When a high-velocity projectile or shockwave strikes the exterior armor, it can cause the interior face of the metal to flake off in high-speed, razor-sharp fragments known as sprawl. To counter this, the interior of the Cougar is lined with a sprawl liner, typically a Kevlar or composite weave, that acts as a catcher's mitt, trapping these lethal fragments before they can shred the crew compartment. One of the most critical yet often overlooked components of the Cougar's survivability suite is the seating. In early military vehicles, bench seats were bolted directly to the floor. In a mine blast, the floor plate accelerates upward instantly, often at hundreds of Gs. This acceleration is transmitted directly through the rigid seat frame into the spine of the occupant, causing fatal internal injuries or spinal severance even if the hull is not breached. The Cougar addresses this with the seat survivability upgrade. These are energy-absorbing seats that are not attached to the floor. Instead, they are suspended from the roof or the side walls of the vehicle. The seats feature stroking mechanisms, essentially shock absorbers, that collapse under the extreme G-forces of a blast. This decouples the occupant from the initial shock wave, allowing the vehicle to lurch upward while the soldier remains relatively stationary for a split second, significantly reducing the vertical load on the spinal column. The Cougar provides situational awareness through large blocks of multi-layered ballistic glass. These windows are incredibly heavy and thick, designed to stop multiple strikes from sniper fire. Crucially, they are equipped with gun ports, small circular apertures that allow the crew to insert the barrel of their M4 carbines or M249 SAW weapons to return fire without opening the doors or exposing themselves to the enemy. This transforms the vehicle from a passive transport into a fighting pillbox. Despite its massive exterior dimensions, nearly 9 feet wide and over 20 feet long, the interior of the Cougar is surprisingly cramped. The V-hull geometry intrudes significantly into the cabin floor space, creating a narrow aisle between the rows of seats. The 6x6 variant can carry up to 10 passengers, plus the driver and commander, but comfort is a relative term. The crew is strapped into 5-point harnesses, wearing full body armor, helmets, and combat loads, squeezed shoulder to shoulder in the Iron Maiden. The operational environments of Iraq and Afghanistan presented a formidable enemy: heat. Internal temperatures in a sealed steel box under the desert sun can easily surpass 140 degrees Fahrenheit, 60 degrees Celsius. To combat this, the Cougar is equipped with dual air conditioning units rated at approximately 24,000 to 48,000 British thermal units per hour. However, the effectiveness of these units was a constant source of contention and mechanical failure. Soldier anecdotes reveal a grim reality. The air conditioning units were often overwhelmed by the lack of insulation, the immense heat generated by the engine and transmission tunnel, and the constant opening of doors during dismounted operations. When the air conditioning failed, the vehicle became a convection oven. Crews would often resort to packing frozen water bottles into their vests or, in extreme desperation, running with hatches open, compromising security for airflow to prevent heat stroke. The electronic equipment inside, jammers, radios, and computers, also generated significant heat, further straining the cooling capacity and often leading to thermal shutdowns of mission-critical systems. Driving a Cougar is akin to piloting a small building from a basement window. The ballistic glass, while protective, is thick and often distorts vision. The hood is long and high, creating a massive forward blind spot that can hide a compact car or a pedestrian from the driver's view. This necessitated the installation of camera systems and the reliance on the vehicle commander to call out obstacles. The blind spots were not just a navigational hazard, but a tactical one, allowing insurgents to approach the vehicle's perimeter unseen in tight urban environments. If the V-hull is the Cougar's hero feature, the electrical system is its villain. The vehicle was originally designed with a standard 12 or 24-volt electrical architecture suitable for a truck. However, as the war progressed, the military bolted on an ever-increasing array of power-hungry electronic countermeasures to jam improvised explosive device triggers, such as the Duke system, along with high-powered radios, Blue Force trackers, and thermal cameras. This parasitic load frequently exceeded the output of the stock alternator. Mechanics faced a constant battle with fried alternators and drained batteries. The original 300-amp alternators were simply too small for the Christmas tree of electronics required for a combat patrol. Upgrades to 570-amp alternators were implemented, but the intense heat in the engine bay often cooked these components regardless. Replacing an alternator in a Cougar is not a simple task. It involves navigating the armored engine access panels, which are heavy and cumbersome, often requiring a crane or multiple soldiers to lift, and the component itself is buried deep in the hot, cramped engine bay. The doors of the Cougar are massive slabs of armor steel and ballistic glass, weighing hundreds of pounds. In the early variants, opening these doors on a side slope was a feat of Herculean strength. If the vehicle was tilted, gravity worked against the operator, sometimes trapping the crew inside. Conversely, if the door was unlatched on a downward slope, it could swing open with bone-crushing force, injuring soldiers standing nearby. This led to the implementation of power assist systems, pneumatic or hydraulic, and improved combat locks. However, these assist mechanisms added yet another layer of maintenance complexity. A failure in the door assist system meant the crew had to manually fight the dead weight of the armor to egress, a terrifying prospect in a burning vehicle or a rollover scenario. The Department of Defense eventually funded specific egress upgrade kits to address these door vulnerabilities and ensure they could be opened even after the frame was twisted by a blast. Before the Cougar, convoys were vulnerable soft targets. The introduction of the mine-resistant ambush protected vehicle changed the tactical calculus. Units could now move with a higher degree of confidence. The Cougar often took the lead position in convoys, acting as a mine roller or a blast sponge. Its survivability allowed aggressive tactics. Instead of hanging back, Cougars could push into kill zones to recover disabled vehicles or extract wounded infantry. One of the most critical roles for the Cougar was as the Joint Explosive Ordnance Disposal Rapid Response Vehicle. Explosive ordnance disposal teams are high-value targets for insurgents. The Cougar provided them with a mobile workshop and a safe haven. The spacious interior of the 6x6 variant allowed for the storage of Talon robots, bomb suits, and disruption tools. The stability of the platform also allowed for the mounting of high-powered telescopic cameras and mast-mounted sensors to inspect suspected improvised explosive devices from a standoff distance. The Cougar's reputation was cemented by the lives it saved and the actions it enabled. One notable example involves Sergeant Joseph Perez, who received the Navy Cross. During a ferocious engagement, despite being wounded, he directed the counterattack from his vehicle, utilizing the protection of the mine-resistant ambush-protected vehicle to maintain command and control under withering fire. Similarly, Gunnery Sergeant Price was awarded the Silver Star for actions involving a Cougar, where the vehicle's protection allowed his team to close with and destroy insurgent positions in a complex ambush. These citations underscore that the Cougar was not just a passive shield, but an active enabler of infantry aggression. The United Kingdom, facing similar threats in Basra and Helmand, adopted the Cougar platform but customized it heavily to meet British Army standards. The 6x6 variant was designated the Mastiff and the 4x4 the Ridgeback. The British modifications were substantial and distinct. Bar armor, also known as slat armor, this cage-like structure surrounds the vehicle to pre-detonate rocket-propelled grenades before they hit the main hull, disrupting the shaped charge jet. The integration of the Bowman communication system and UK-specific electronic control module suites required significant internal rewiring. In true British fashion, the Mastiff is equipped with a boiling vessel, a tank-grade electric kettle used for heating water for tea and rations, a standard morale and tactical requirement in British armored vehicles. Wolfhound, a tactical support variant based on the Mastiff but featuring a rear flatbed for cargo, allowing for protected logistical support to forward operating bases. Despite its success, the Cougar had limitations. Its sheer size and weight restricted it to main roads and firm terrain. In the rural mountains of Afghanistan, the heavy Cougars struggled with narrow trails and bridge weight limits, often collapsing culverts or getting stuck in wadis. This led to the development of the MRAP all-terrain vehicle, a lighter, more agile vehicle that bridged the gap between the Humvee and the heavy mine-resistant ambush-protected vehicle. As the wars in Iraq and Afghanistan wound down, the U.S. military faced a decision on what to do with its thousands of mine-resistant ambush-protected vehicles. While many were scrapped or sold to allies, a core fleet of Cougars was retained and modernized. The Cougar Category 2, A1 upgrades focused on the seat survivability upgrade, automatic fire suppression systems, and the standardization of the TAK-4 suspension across the fleet to ease logistics. The transfer of Cougars to the Ukrainian Armed Forces in 2022 and 2024 opened a new chapter in the vehicle's history. Unlike the counterinsurgency operations for which it was designed, the war in Ukraine involves high-intensity conventional combat with heavy artillery, drones, and dense minefields. The Cougar's V-hull has proven effective against the diverse array of Russian anti-tank mines. Its mobility in the famous Ukrainian mud, Rasputitsa, is tested to the limit, relying heavily on the 6x6 configuration and independent suspension to maintain momentum in conditions that would swallow a lesser truck whole. The Cougar mine-resistant ambush-protected vehicle is not a pretty vehicle. It is a towering, blocky, intimidating slab of industrial military engineering. It handles like a cement truck, drinks diesel with abandon, and frustrates the mechanics charged with keeping its complex electrical veins pulsing. It was never designed to be the perfect combat vehicle. It was designed to be the necessary one. From the drawing boards of South Africa to the factories of South Carolina, and finally to the cratered roads of the Middle East and Eastern Europe, the Cougar represents a triumph of survivability physics. It proved that in an era of asymmetric warfare where the enemy strikes from below, the best weapon is often simply a hull that refuses to yield. If you found this analysis useful, really helps more people discover these deep dives. Thanks for watching. It is a mechanical beast that became a guardian, earning its gold standard reputation not through sleekness or firepower, but through the dull, violent thud of explosions that failed to kill